gathering data unit, you might think that we're ready to dive into visualization, pandas, and the like. But there's one important question to consider. Will your data gathering procedure scale, and can you trust the process? When you get to the point of deploying a model in production, you will likely need to automate the training of that model with new data. In this unit, you will learn why it is important to assess the maturity and reliability of your data gathering processes. This has traditionally been known as the extract, transform, and load process, or ETL. In the simplest possible definition, this part of the data science workflow is the process of moving data from a source location or locations to another target destination. The first step is to extract, and in practice, this often means pulling from heterogeneous sources. After the data are collected, the next step exists to aid quality assurance. For example, does the same user exist in duplicate within your SQL query? Are dates in a standard format? Do you need acoustic beamforming before you can make use of your audio data? The final step is to load the data in a target destination. Try to keep in mind that the goal here is to make the rest of the AI workflow easier by taking some steps toward automation. One important limitation to the traditional ETL philosophy is that up front in the process, decisions have to be made about which data are going to be important. Sometimes the specific data or form that the data must take is not evident. This may occur because the best target data for a given model may not be the best target data for another model. There is a need in the AI workflow for automation, but it has to be balanced with some amount of flexibility, especially in the initial iterations through the workflow. For these reasons, we refer collectively to the content of this part of the AI enterprise workflow as data ingestion rather than ETL. Cleaning, parsing, assembling, and gut-checking data are among the most time-consuming tasks that a data scientist has to contend with. The problem is not new. Statisticians conceded decades ago that it was just part of the job. We've all heard some form of the phrase, bad data yields bad results. Here's an example. You want to train a recurrent neural net to infer proper grammar. It does not take an expert in deep learning to predict the type of results you'd get if you used YouTube comments during training. Problematic data is generally more subtle and nuanced than the example just given, which is why it is important to write tests to ensure that your data pass a minimum bar of quality assurance. In this unit, we will dig into data ingestion and some of the technology solutions like data warehousing. There are enterprise-level solutions offered by IBM for data warehousing and testing. In this unit, we will focus on a combination of IBM Watson and open source tools to carry out this part of the AI workflow. It's important to note that you will likely not be solving this part of the process on the first iteration through the AI workflow. In fact, you should not. You'll want to get through the entire workflow, keeping in mind the guiding phrase, make it work, then make it better. The working example will illustrate this process with text data and sparse matrices.